Assalamu alaikum dear friends. Today in this video we are going to talk about work energy theorem. Let's look at the definition or statement of the work energy theorem. Statement states that the work done by the net force on an object is equal to the change in its kinetic energy. Here we are going to encounter with a new term, the kinetic energy. What is the kinetic energy of an object? So let's first demonstrate the kinetic energy of an object. Suppose that its definition is energy possessed by the body by virtue of its motion. Suppose if an object is here and we are going to apply some force on it, suppose F, and the mass of the object is m. On applying the force F, the body will go under the change. What kind of change will its body go? So there are many kinds of the changes, but the basic is it will change its position. Number one is position, and this number second is the velocity. So these are the two changes that the body A, suppose the body A is going through. Now let's see what the kinetic energy is equal to. Kinetic energy of a body, if a body is going through some acceleration, if any force, suppose a kind of force is applied on it and it goes through the change, that it changes displacement from this position, suppose this position to this position. During this change, the body changes its velocity. Suppose if the initial velocity of the body is u and the final velocity of the body is v, this is the final velocity of the body as it has attained after going through this displacement from A to B. Remember that body always moves in the direction of the applied force. If the force is applied in this direction, the body will move along the direction of the force. Now let's derive the equation of work energy theorem, that's W is equal to force into distance. Here we have to derive W equals to 1/2 of m v square minus u square. This is the work energy theorem equation and we have to derive it. Let's take a body. Suppose an example of a body. Suppose this is the body A. It has mass of m and a force of F is applied on it, and it goes through the change, that it changes its position from A to position B. Mass of the body will not change because in classical mechanics mass remains the same. Only velocity of a body will get changed. Suppose at position A its velocity was 0, initial velocity, and at position B its velocity be v. So the body has gone through the change from position A to position B and from velocity u to velocity v. Now let's take the equation of work, that's small work done on the object, to be dW. We know that dW is equal to F dot ds. Force applied on the object and the displacement it has gone through, ds. We know by applying the Newton's second law of motion, F equals to ma. This is the second law of motion, Newton's second law of motion. Force applied on any body is directly proportional to the acceleration produced in the body. F directly proportional to A, or we can say F equals to ma. We will study this topic separately in the next video, in the different video. So here I am just using this equation in the equation first. Suppose this equation first, and now suppose dW equals to F dot ds. This is the small displacement the body has covered. Suppose this body has covered a small displacement from position A to position B. This is the small displacement ds, and we know F is equal to ma. Substituting value of F in the equation dW equals to F dot ds, so dW will be equals to mass into acceleration into small displacement ds, and dW will be further written as m into, we know that acceleration of a body is rate of change of its velocity, that's dv by dt, dv by dt, acceleration of a body. So substituting the value of a as dv by dt in this equation, so we will write in place of a as dv by dt multiplied by ds. We know that this factor ds by dt, ds by dt is equal to v, that's the velocity of an object, or we can say instantaneous velocity of an object, is equal to ds by dt. That's in place of ds by dt we can write v, so dw will be equal to m dv into v multiplied by v. Now let's see how much change the body has gone through. Suppose that we are applying a force F1 on this object here at this position, another force F is applied at this object at this point, suppose F2, and similarly many forces were being applied on this object at the different spots, and it will go through the certain changes that I have already mentioned. It will go under many changes, through many changes like change in the displacement, change in the position, change in the velocity, and it has changed the velocity from u to v. Now here the variable term for us is that the terms that have gone varied from one value to another value, or from one position to another position, is mainly the velocity of an object, because mass is the constant term in the classical mechanics. I am again once again mentioning this thing, mass is constant. Only one thing that will vary will be the velocity, and change in velocity brings the body into the motion. When the object changes its position from one place to another place, then the body is said to be in motion, or if it changes its position with respect to the time. So here again I will write, if dW is equal to, previously mentioned here, dW is equal to m dv multiplied by v. Now here dW is equal to m v dv. Suppose that now this is the small work done on this object, small work done. Suppose this is object A, it has mass m. I am showing here the figure. Small work done is dW, and if we calculate the total work done on this object, we will integrate this dW from w equals to 0 to w equals to w, full work w, which is equal to m. We can integrate how much change in the velocity has occurred, so we can integrate v dv from velocity from u to v, final velocity v. U is the initial velocity and v is the final velocity. Now dW, integrating dW, that we get w from 0 to w will be equal to mass m multiplied by, integrating v, we can get v square by 2 from u to v. Now giving the limits, we can write here w from the limits 0 to w is equal to m into v square by 2 from the limits u to v. Giving the limits here, we can write w minus 0, which is equal to m, giving first upper limit, that's v, this is upper limit v, so it will be v square by 2, minus giving the lower limit, it is u square by 2. So w minus 0 is equal to w, that's work done, is equal to m into, we can take 2 here as common, v square minus u square, or we can write here w is equal to half of m into v square minus u square, which is termed as the change in kinetic energy. this change in kinetic energy is equal to the work done on the object. That's we have to prove. So this was a video about the work energy theorem. In the next video we will meet again with a different topic. Till then, Allah Hafiz. If you find this video helpful and useful, then please subscribe to our channel and like the video and follow our page.